we'll revisit the web request exercise in a few minutes. Previously, we had been fetching CSV formatted data. Maybe we're using some pandas to do that, but we will learn how to process JSON data. So what does that mean? What does it mean for us to be working with the internet? I'd like to launch into some slides for about 10 or 15 minutes. We'll set the stage with some high-level concepts. What is the internet about? How does it work? And you'll see these concepts will translate directly into the techniques that we'll use to request that data in Python. All right. This unit is about fetching data from the internet. So like, what is the internet about? I know that all of us have used the internet and use the internet on like a daily basis, but let's just take a step back and talk about what it means for us to be doing that. So networks are how computers and devices transmit data to each other. These networks can be wired or wireless. And so examples of wireless connections would be like Bluetooth or Wi-Fi. Whereas wired, if you've ever like plugged in like an Ethernet cable to the wall, that's an example of like a wired connection between devices. Or even you hooking up some old school headphones into an actual device like non-Bluetooth headphones. If anybody has any of those old headphones, that would be a wired connection where there's a physical cable connecting the devices. This barcode scanner would be another example of that physical cable connecting the devices. So the devices can connect with each other either wirelessly or through some wired media. When devices are connected with each other, that's what comprises this network. And when we talk about networks, we can characterize them by their size. So the smallest version of this is a personal area network. So if you're walking around Georgetown neighborhood with your mobile phone and like some Bluetooth headphones, maybe even like a wireless hotspot, as you move throughout the city, that network moves with you. And so we can call that like a personal area network. It's around your person. Could be mobile with you. When the network grows in size, we call that a local area network or LAN, if you've heard of that term. And so example of this is like a Wi-Fi network in a house. It will cover a range of like a few rooms, and anywhere in those rooms you can connect to the network. As it starts to grow, we can call a larger network a wide area network or WAN. And an example of this is like the university network, which covers the entire campus. And so these networks can keep connecting with each other and connecting more and more devices. And eventually, the largest network of connected devices in the world and even in space is the internet. So we have the mechanism of connecting devices and transmitting data across the world and into space, but how can that happen? We need some rules of the road. So if you've ever heard of some of these internet protocols, these protocols govern how the internet works. And if we want to participate in sending and transmitting data, we have to learn about these protocols so that we can use them. The most popular protocol or most used is HTTP. So when we type a URL in the browser, really what we're doing is using that HTTP protocol to make a request. And we'll see an example of this in a sec. HTTPS is a secure version which encrypts the data. But there's other protocols for different purposes, like if anyone's ever used an FTP or file transfer server to upload some files to a server. Or SMTP is actually the protocol used to send email. So when you send an email, the SMTP protocol is being used. We could use the SSH protocol to remotely log into other computers and servers. And so there's just different protocols for different purposes, but primarily we're focused with HTTP. And you could think of HTTP as like the rules of the road that help devices transmit data and essentially communicate with each other over the internet. So you could think like if a native English speaker is on vacation in Japan and trying to communicate with some folks there who might not speak English, and this native English speaker might not speak Japanese, there's only so far those individuals can go to communicate with each other. Maybe hand signals, some awkward Google Translate pauses. But if individuals speak the same language, that will allow them to fully communicate with each other. And so HTTP is like the rules of the road that allow different devices to essentially like speak the same language. So what is HTTP about? It's really just about requests and responses. So when you think of HTTP and the internet, I'd like for you to think of requests and responses. And also, we're talking here about what's called the client-server model. This is a two-step process whereby one computer makes a request. Hey, can I have some data? Can I have the Georgetown website? We can call that computer the client. Its responsibility is to make a request. Another computer somewhere, its responsibility is to field that request and return a response with the requested data. So there's a two-step process here. One computer makes a request. Hey, can I have some data? And then another computer is like, sure, here you go. So that's what HTTP is about. And we can call the role of the requesting computer the client, and the role of the computer that returns the response, we call that the server. And so a lot of the times when we're requesting data from the internet, the server, the computer that's returning the data, is just some monitorless, keyboardless computing device, maybe in some Amazon data center somewhere. But for example, Georgetown has set up some server somewhere to respond with the Georgetown website anytime someone requests it. So let's take a brief detour into the browser and see this in action. All right, so we all know how to use the browser. We all know how to like type a URL into the search bar, like georgetown.edu. And then we see a website. Great, it's kind of like magic, but let's unpack this a little bit. When we use the browser, that's the most popular way of making a request. Here we see that the URL bar reflects the HTTPS protocol. That's the first part of the URL that we actually visited. So the HTTP protocol is essentially helping our request find some server operated by Georgetown. There's like a DNS routing process that helps our request find the right server. And somewhere Georgetown has set up a server to respond to our request with this website. All right, so we made a request, the server gave us the website. But here we see like moving images, like what is this website about? What is the data that the server responds with? In any modern browser like Chrome or Firefox, you should be able to inspect the underlying contents of any web page. And this is kind of fun. So we could like right click anywhere on any web page. I'm using Google Chrome as my browser, but you could do this in Firefox as well, and maybe some other browsers. We could just right click anywhere on the page and then just say like inspect or inspect element, depending on what browser you're using, or like view inspection tools. You might have to configure them in your settings, maybe if you're using Firefox. But anyway, after right clicking on the page and inspecting the underlying contents, now we can actually see what data got returned by the server. So all the awesome visual content that we see in the browsers, it's kind of able to somewhat magically translate the underlying data that got sent by the server and visualize it in a human friendly way. So really what we're looking at here with the Georgetown website is what we see on the right, all this text. And there's a lot of it, and it might be intimidating. All this HTML formatted text. We'll return next week to actually see if we could programmatically parse the content of this HTML. And it's a little more complicated and involved, and it actually depends on which page we're visiting because each page can be structured differently. So we'll return to programmatically parsing this content, the HTML content of any website in the future. But anyway, I'm just showing you right now that when the server responds, it's actually giving us this document of text. And depending on which URL we requested, the document that gets sent back might look different. It might be HTML, it might be JSON data, it might even be a CSV file. So depending on what type of data we're working with, we might need to adjust our parsing strategy accordingly. Anyway, though, I just wanted to do this demo to show you like what is being returned by the server. It's some text. And if this text has a structure to it, if there's a method to all this madness, maybe we could parse it. All right. So I think that's all I'll do with that Georgetown website demo for now. And let's just get back into the slides for a few minutes. We're talking about client and server. One makes a request, the other fulfills the request and gives a response. So some final considerations for us to think about when we are using HTTP. We know it's about requests and responses. And when we make a request, there's actually a handful of different specific kinds of requests that we could make. Get, post, patch, delete. The most popular type of request that we will make is a GET request. And whenever you type a URL in the browser, you're actually making a GET request. Hey, can I get some data? Hey, server, can I have some data back? Can I get a web page? Hey, API, can we get this data? That's a GET request when we ask for some data. But there's other types of requests as well, like a post is actually asking the server to take some data that we send to it. So like if we are making a tweet, for example, creating a new tweet, when we type in our message and press that button to actually create that tweet, behind the scenes, most likely a post request is being initiated to the Twitter API. And it's saying, and we're saying like, hey, Twitter API, here's this tweet text. Will you store it in your database so that it will always show up on my profile and all my followers could see it? That's a post request. Hey, let's send some data. Server, will you accept this data that we send you? It's still a request because the server it's not obligated to take your data. So anyway, there's different kinds of requests, but the one that we'll be focusing on most is the GET request. Hey, can we get some data back? If you need to like update your profile, maybe a patch request would be made. If you need to like delete a tweet, maybe a delete request will be made, requesting to remove some data from the server. So there's just a handful of different types of requests that can be made. And so what we'll see is that when we make these requests in Python, depending on which type of request we want to make, that we have to like specify, oh, we're going to make a GET request or a post request or whatever. So we'll see us making GET requests in a few minutes. So that's the request side of things. There's a handful of different kinds of requests. On the response side of things, there's also a handful of different status codes. In other words, when someone makes a request, it could go a few different ways. The server could handle it and fulfill that request successfully, or maybe there could be like an issue along the way. And so when the server responds, it will also usually provide a response code to let the client know or let the requester know how the request went. Will we see a status code in the 200s? That means our request was successful and we should get that data that we requested. Sometimes if we request a page that moved, we might see a redirect, a code in the 300s. But I'd say 200s and 400s are the most common thing that we'll see. Sometimes we might see 400 errors, like if we're not supplying our credentials properly, or if we requested a page that doesn't exist. On some websites that you may be familiar with, you might even see some meme content come up like page not found error 404. If anybody's heard of like a 404 error, it just means like the page or resource you requested doesn't exist.